Hey guys, what you're looking at is not a regular power supply. It's actually a homemade lab power supply made from an ATX power supply. See how it powers a soldering iron without any voltage drop and delivers nearly 11 amps. In this video, I'll show you step by step how to turn a simple computer power supply into a real powerful power supply. Yellow wire, 12-volt output for high-power consumers. Purple wire, 5-volt standby. Green wire is power on the base which, when connected to ground, starts the power. And black wire is ground or negative circuit. Now let's move on to opening the device. The first thing we do is unplug the AC power port. Now, for better access, we will separate the circuit from the metal frame. To make the power supply more stable at high currents, we are upgrading the capacitor. The factory capacitor on this power supply is 330 microfarads. But now, we are replacing it with a 470 microfarad capacitor. The input rectifier section used 4 conventional diodes to convert AC power to DC. But these diodes heat up faster under heavy load and have a higher voltage drop. Therefore, we upgraded this entire section with a 10-amp integrated diode bridge. Since this power supply is supposed to be a variable power supply, the output section also needs to be prepared for higher voltages. The factory output capacitors are designed for a standard 12-volt constant voltage, but when we increase the output voltage, they may be stressed and explode. Boom. The heart of this power supply is the TL494IC. To make changes, we will disconnect 3 important pins of this IC from the circuit. Pin number 1, which is responsible for controlling and regulating the output voltage. Pin number 15, which is related to current control and is used to adjust the current limiter. And pin number 12, which is the main power supply of the IC itself, VCC, so that later we can use this pin for the short circuit protection circuit. And now we solder a separate wire to each of the 3 IC pins. This is where pin 12 of the IC was previously soldered to. Solder a separate wire to it. Pin number 4 of this IC is the dead time control part, so we connect pin number 4 directly to ground to disable the IC's internal protection and limiter. We place a 1 kilo resistor between pin 16 of the IC and ground. Finally, we place a 10K resistor between pins 14 and 15. Be very careful. This 10K resistor, along with the 1K resistor on pin 16, determines the output current of our source. Now we will use 2 10K multi-turns to vary the voltage and current. It is better to use a multi-turn volume instead of a potentiometer because a multi-turn is more accurate. Now our power supply is built and we are going to make it resistant to pressure and heavy load, optional. Here heatsink A is for the BJT transistor and heatsink B is for the Schottky diodes. If you have a larger transformer, you can replace it, but if you don't, the same old version will do. Now that we've upgraded almost all of the power sections, it's only natural to upgrade the output inductor as well. We upgrade the 13007 power transistor to a 13009 transistor, optional. Now it's time to upgrade the Schottky diodes. It doesn't matter what number they are as long as they can handle 10 amps or more, optional. I was forgetting that the voltage for the device's cooling fans must be supplied from a constant source, so we convert the 5-volt standby voltage to 12 volts using a boost module and supply it to the fans. This module displays the output voltage and current consumption in real time. The thick red and black wires are for the main output current. The thin red and black wires power the display itself. And the yellow wire is used to measure the output voltage so that the exact voltage value can be seen on the display. Finally, the positive output of our power supply becomes the +12 yellow wire, and the negative output becomes the thick black wire. Now we connect the IC's VCC power supply, that is pin 12, which we previously disconnected, for testing. The generated voltage can be adjusted from 1 to 28 volts, and its current from 1 to 11 amps. Now let's move on to the short circuit. You definitely need a 12-volt relay, 2 green and red LEDs, a push button, 2 BC547 transistors, 2 1.5 kilo ohm resistors, and a 5.6 kilo ohm resistor, 1 N4007 and 1 N4148 diodes. And then we move on to assembling the circuit. To make it look more professional, you decorate the body with carbon fiber stickers. Connect the device fans to the output of the XL6009 module and set the module voltage to 12 volts. And now, it's time for the final test of this homemade power supply. I connected a powerful 24-volt gas lamp to test the load, which requires a lot of current. As you can see, the power supply works quite stably and without voltage drops. And most importantly, the short circuit protection circuit works perfectly. Now, without heavy expenses and without buying an expensive laboratory power supply, you can make a powerful and professional power supply from an old ATX power supply. Isn't that amazing? If you like this video, be sure to like, subscribe to the channel, and leave me a comment.